All right, for this example, we've got a couple of proportions, two samples. I'll let you read the context, but essentially we got to go through the whole process here. So state, plan, do, conclude. We're going to start with the state part. So we want to make a statement about what we're about to do and make sure that we include the alpha level. So here's what that looks like. So again, context, we talk about true difference in proportions and alpha level. Those are the keys here. So reading the context here, we've got instructor A and instructor B. Our null hypothesis will be that there is no difference between the proportion of students of instructor A's students that pass and the proportion of instructor B students that pass. So that looks like this. Alternative hypothesis. The alternative is that essentially instructor A is more effective than instructor B. In symbols, it looks like the proportion of instructor A's students minus the proportion of instructor B's, or in other words, the difference is going to be greater than 0 because A is more effective, so he has a higher proportion. So we've got our null hypothesis and our alternative hypothesis. And again, we've introduced some terminology here. So we want to make sure that we define that notation P sub A and P sub B. And so that's what this looks like. All right. So we've got our state step done. So let's go ahead and move on to the plan step. And in the plan step, we always check the conditions. So our three conditions are these. So we got number one, both groups have to be randomly selected. So let's just go back up. An incoming class of 100 students is randomly assigned to two groups. So random assignment will do the trick there. Less than 10%. So we've got each of size 50. And each of size 50 will assume that 50 is less than 10% of all drivers or of all people taking the exam. All right, so in this case, we're not going to be checking NP and NQ. We're going to be checking the successes. So if we look up here, we've got 30 of instructor A's. Students pass, so we've got 30 successes. That's obviously bigger than 10. And also failures, 30 out of 50, we've got 20 failures. So for instructor A, that works. For instructor B, we've got 22 successes, so 22 successes greater than or equal to 10, and then 28 failures greater than or equal to 10. So this checks out. We can assume that the sampling distribution is normal or approximately normal. All right, so now we're going to go on to the do step. Here's where we specify the test. This is a two proportion z-test. So we want to specify the stuff that's important about running this test. So because we're using our calculator for most of this, there's only a couple things that are important here. Number one is the p hat. In this case, because it's a proportion, or it's a two proportion z-test, and we're operating under the assumption on our null hypothesis that these two proportions are the same, we're going to use a p hat pooled. The calculation for that looks like this. And so we have a pooled sample proportion of 0.52. So the next thing that we need to make sure that we incorporate or report is our z-score. And we're going to use that pooled proportion when we piece together the calculation for the z-score. So remember, you don't have to necessarily show the calculation. You definitely have to report it, though. And you should know how to calculate each one of these by hand. So let's go ahead and calculate the z-score. The z-score is going to be the difference between my sample means minus the true mean difference. So the difference in my sample means is 33 out of 50. Sorry, 30 out of 50, which is 0.6, minus 22 out of 50, which is 0.44. There's the difference in my sample proportions. And I'm going to subtract the true difference between my proportions, which we've assumed, again, from the null hypothesis to be 0. In my denominator, this is where the pooled standard deviation comes in. So when we pool this, we've got a p hat of 0.52. We're going to multiply that by the complement of 0.48 divided by however many are in the sample. And because we've assumed that these two samples are the same, the second calculation is exactly the same. So there's what it looks like pieced together. Simplify and you get this with a z-score of about 1.6. So let's actually run the test. I'll show you the calculator steps here. We'll actually run the test and we'll get a p-value from our calculator. All right, so we go over to the Inspire. I'm going to hit menu, go to statistics, go down to stat tests. This is a 2 proportion z-test. The number of successes in my first sample, if you remember, I got 30 successes out of 50. And my second sample is instructor B. I got 22 that passed out of 50. And in this case, we're running a one-tailed test because we want to know if instructor A is better than instructor B. So P1 greater than P2 or P sub A greater than P sub B is what we're testing. You run that test and this is what it spits out. So we've got our z-score that we calculated over here. The p-value is what we're interested in to make our decision. And then again, it also spits out some other interesting stuff. Here's your pooled sample proportion, your pooled sample proportion of people that pass the test. And it's got some other information in here as well. So for right now, a p-value of 0.055, we're going to use that and make sure that we report that back under the do. 0.055. All right. Last but not least is our conclusion. And in our conclusion, we're always going to start with a comparison of our p-value versus our alpha level of significance. So that looks like this. With a p-value of 0.055, we fail to reject. So the next thing we're going to include is a decision about the null hypothesis at the alpha equal 0.05 level of significance. And then what comes next just has to do with the context. So we're just going to talk about what it means to fail to reject the null hypothesis within the context of the problem. And that looks like this. We do not find significant evidence for a difference in proportion of instructor A and instructor B students that passed the driver's exam.